Bismillahirrahmanirrahim. This is part E of lecture 5 on Descriptive Statistics and Islamic Approach. In the previous portions of this lecture, we have discussed the defects of the original approach to statistics pioneered by Sir Ronald Fisher. In this lecture, I want to illustrate the difference in the context of a real life example, one that we have already studied in an earlier lecture. So to illustrate this new approach, we will look at the already studied example of Australian inflation. What is of great importance in understanding what follows is that the data is all that we have. The statistical assumptions that are added by the Fisherian approach do not provide us with additional information. These statistical assumptions are arbitrary and unverifiable, but all of the inferences made in the Fisherian approach are based on those untestable and generally false assumptions. So basically all of the machinery of conventional statistical inference leads to false and unreliable conclusions. The first step of a real data analysis is to just look at the data. In this case, we are looking at prices and money data, but this is not just look at any data, it's look at data which is connected by some theory that we want to assess. So basically here the theory that we have in mind is the Friedman idea that all increases in prices are due purely to increases in money. So here we just look at the data on the prices in money that's displayed in this graph. And this graph immediately shows us that this relationship, if one exists, is not strong, as not obvious to the eye. There is no strong direct relation between money and prices. You can look at the graph and you can see that in the early portions of the graph, the prices are rising quite rapidly, but the money supply is not rising rapidly. In the middle period, both of them rise at roughly the same rate. Towards the final period, the money is rising fast and the prices are rising slowly. So there are clear differences in the trends between price increases and money increases. The second step in a real data analysis is to look at the data in a clever way by breaking it down, by visualizing these items, by focusing on those things which are of interest. In this case, we're not really interested in the price series and the money series, we're interested in the change. We want to say, the theory that we have says that the increases in money stock are the cause of increase in the prices. So we have already seen earlier that the best way to define increases, the rate, is by taking the log of current to past period. This makes changes additive across periods. So here we just graph these two series. Percentage P is the log of current price over past price, and percent M is the log of current money over past money. And this graph shows that there are some rough correspondences. It doesn't show that they are completely unrelated series. There are obviously, these two series follow similar trends, but there are clearly spikes in prices which don't seem to be related to spikes in money. And so we could say that there is a rough correspondence between prices and money, but it's not very perfect, and there are many things which remain to be explained. The third step is to analyze the data in ways which are suited to the question we are asking. In this particular case, we want to look at the association between changes in money and changes in price. The association is symmetric relationship, but causation is one directional. We cannot assess causation by data, but we can look at association. The standard method from the Fisherian approach is to assume that the data is jointly normal. Once we make that assumption, then the best formula for measuring association is called the correlation coefficient, which has a complicated mathematical formula. The problem is that this method works very badly if the data is not normal. So if we can just assume that these series are jointly normal, then we would apply the correlation coefficient, but This is not a good method in general, and there is no reason to assume that the change in price and change in money would be jointly normal. There is just no evidence and no way to think why this should be the case. It's just an arbitrary assumption. Instead of making arbitrary assumptions, let's do something which is intuitive and natural. Let's divide the series of price change and money change into high and low, and look at the question of whether high changes in money are associated with high changes in price. Now, how can we make this division? We just sort the data into an ascending order from the lowest price increase to the highest rate of price increase. And then we just chop the series off at the middle. So the bottom half is the price changes which were less than the median, and the top half are those which are above the median. And similarly for money. So the high money changes are the ones which, over these 60 years of data that we have, the 30 years that are the highest ones for price change are called high, and the 30 years which are the lowest, are lower than the others, are the low money changes. And similarly, we divide the price changes in this way into two portions of 30 and 30. And now we see if high money changes correspond to the high price changes or not. This is a natural and intuitive method which doesn't rely on complicated formula. Here's a chart for highs and lows in changes in money and changes in price according to the principles discussed in the last slide. Now when you look at this chart, you notice that money in the blue in the bottom graph stayed low. The rate of changes in increases in money were low from 1961 to 1971, with the exception of two periods, 1963 and 64, they were high. If you look at the corresponding behavior of change in price, you find that it was low from 1961 to about 1969, with one spike in 1967. So then the question arises, did the high money in 63 and 64 lead to high inflation in 1967? Knowing about money and prices from our knowledge of the real world, we can say that this is probably not true. Probably high money in 63 and 64 did not have an impact on inflation 3 years later. This depends on our knowledge of the real world. Then there is a second question, that the money price increases became high in 1971 and remained high until 1991. So why did inflation become high in this decade 69 to 90? Probably this had something to do with the oil prices increases, but maybe there were other factors. And note that the changes in money became high from 1980, from 79 to 91, which is much later. Although there were erratic periods, money was going high and low, increases in money. So all of these raise questions. Could it be that as the inflation was increasing, the Monetary Policy Committee decided to follow an accommodatory money policy? If the needs of the business become high because of inflation, then you print more money so as to enable the business to be done. This is one of the theories of money. So these are the things, these are the questions about the real world which arise from looking at these charts. So the same data leads us to very different kinds of questions in the Fisherian approach and in the real approach. According to Fisher, the data that we see are random draws from a hypothetical population. What matters is the parameters of the imaginary population. So if we know those parameters, if we know the imaginary population, then we don't need the data, because the parameters provide us with all the information that is contained in the data. This is called the theory of sufficient statistics. So in particular, individual data points do not matter. They don't contain information because they are random. A point that is currently high could, on the next time around, by a random draw fluctuation, could be low. So it doesn't make sense, according to Fisher, to analyze the individual data series point by point as we are now doing. In real statistics, each data point matters. It is not something that could be randomly chosen from a hypothetical population. It's not something that could come out different. We have in the data that over 79 to 91 period, in the decade of basically the 80s, the increase in money became high. So now this is not something from which we go to an imaginary population to find the population parameters. We try to understand this particular fact. This is a fact about the real world. So then we look at the Australian economy. We look at methods of money creation. We look at the reasons why extra money was created. We could look at the bulletin of the Monetary Policy Committee. How were they making decisions about the money? Were they accommodative or were they forward-looking? What were the variables that they discussed in order to decide upon how much money to create? But also we can look at private money creation by financial institutions. It turns out that we know from history that 1980s was a period of financial deregulation. And when financial deregulation takes place, more money can be created by the private sector. And maybe that's the reason why increase in broad money was high over this decade of 1980s. So all of these questions we cannot answer by looking at the data itself. We have to go beyond the data and look at the real world mechanisms which were created. We also want to look at how strongly increases in money are associated with increases in price. And as we have already said, the correlation measure is very bad for this purpose because it only works when the distributions are normal, and we have no reason to believe that these variables that we are studying, this data, is normal. So one very simple and intuitive way to check the association is to divide the data into two halves, as we have already done. And then we look at the half of the data, the 29 data points on which the percentage increase in money was low. And we look at what happened to the price in these cases. And when we just count, we find that in the 29 periods in which the rate of growth of money was on the bottom half, in 20 periods, the rate of increase of prices was also low, but in 9 periods, it was high. And similarly, when we look at the other 30 periods in which the money growth rate was high, we find that the price was also high in the rate of increase in prices was high in 21 periods, but in 9 periods it was low. So from this, we see that there is an association. When percentage increase in money is low, the tendency is for there's a 2/3 chance of price increasing being low, but there's also a 1/3 chance of price increase being in the other direction, different from the money. So there is a strong association between percentage money. It's not 50-50. It's not equally random. The rate of increase of money has an influence on price, but it is not overwhelming. It's not 100%. And so we should probably look to other factors which would explain the price increase in addition to money. This graph, this chart shows that there is a relationship, but it's not overwhelming. It's not that money is the only source of price increase. So from this basic analysis of data points themselves, without any stochastic assumptions, without any normality, without any randomness, we can see that there is a strong relationship. About 66% of the times, both percentage change in money and percentage change in price are either both high or they are both low. But about 1/3 of the time they go in opposite directions. The change in money is high, but the change in price is low, and vice versa. So there is a strong relationship, but it's not overwhelming. The direction of the causation cannot be told from the data. We can just see that the two are related. To find out about causal relationships, we have to go beyond the data, because data can never tell us about causality. So we can look at the monetary policy and what they were doing, and we look at the private sector, bank, financial sector, and look at histories of what they were doing in that period. So from this we learned that direct analysis of the data without any assumptions gives us a lot of information about the real world. And one more important thing is that there is no other information. The data is all that we have. The Fisherian approach adds stochastic assumptions. It says that this data is a random sample from a hypothetical population. This assumption, which is completely unverifiable and basically false, it's just made for computational convenience, it actually reduces the importance of the data, because it tells us not to analyze the individual data points, and it focuses our attention on the wrong thing, how to estimate the parameters of this hypothetical population which doesn't exist, instead of looking at how does this data, what is the information this data is providing about the real world. So this summarizes in the major differences between real statistics that we are advocating and the Fisherian approach, which is the dominant and approach to statistics these days.